Hello everyone. Today we talk about Green's theorem. So I want to discuss some problem related to Green's theorem. So first I am going to discuss verify Green's theorem. Okay, verify Green's theorem. Integral over C 3x squared minus 8y squared dx plus 4y minus 6xy dy, where C is the boundary of the region bounded by y is equal to x squared and x is equal to y squared. Here verify Green's theorem means you can evaluate a left hand side separately and right hand side separately, and finally you can conclude that both left and right hand side will have the same answers. Therefore Green's theorem is verified. Okay, before we are going to solve the problem, first I am going to write the statement of Green's theorem. Green's theorem states that integral over C p dx plus q dy equal to double integral over r dou q by dou x minus dou p by dou y dx dy. You can mark it as equation number 1. So generally Green's theorem is the relationship between line and area. Area in the sense double integration. Okay, double integral over r. So now I am going to evaluate left hand side and right hand side separately. So first I am going to evaluate right hand side, that is double integration. Integral over C 3x squared minus 8y squared dx plus 4y minus 6xy dy. So first you can identify what is P and what is Q in this. So you just compare the given question with the statement of the Green's theorem. So P dx. So here what is your P? 3x squared minus 8y squared. What is your Q? 4y minus 6xy. Okay. After this, what we are going to do? We are going to manipulate partial derivative. So what do you mean by partial derivative? So here I am going to differentiate Q partially with respect to x. That means we are treating other variable as constant. Here the other variable means y is constant. I am going to differentiate Q partially with respect to x. That means we are treating y as constant. So first term is 0. What about second term? Minus 6y is constant. Now you can partially differentiate with respect to x. With respect to x means 1. So the answer is minus 6y. Similarly, I am going to manipulate dou p by dou y. Dou by dou y of 3x squared. Now I am going to differentiate partially with respect to y means we are treating x as constant. So first term 0. What about the second term? Minus 8 into, with respect to y means 2 into y. 8 into 2, 16, minus 16y. Now you can substitute in this. Dou q by dou x is minus 6y, minus of minus, so 10y. Now the integral becomes double integral over r 10y dx dy. Okay, this is the first step. Next, what we are going to do, I am going to evaluate this integral. For that, we need region of integration. The innermost integration is with respect to x. Corresponding limits for x is either functions of y or constant. So, how do you find the limits? For that, we are going to sketch the diagram. Here, the diagram is C is the boundary of the region bounded by y is equal to x squared, x is equal to y squared. Now, we will discuss x is equal to y squared and x equal to x squared. So how do you manipulate x is equal to y squared and y is equal to x squared? It represents a parabola opened in the right. It represents a parabola opened in the upward direction. So this is red color color will represents a parabola. X squared is equal to y, that is upward direction. This is downward direction. So using this, I am going to find the limits for x and y. The innermost integration is with respect to x and r. We are treating y as constant. Y is equal to constant means a line parallel to x-axis. So I am going to draw a horizontal strip. In that, throughout the region, the ends of the strip should be the same. So how do you find the limits? Left to right. So you can find the limits from left to right. So left end of the strip will falls on the parabola y squared is equal to x. In that you can express x in terms of y. So x is equal to y squared. So left hand limit is y squared. What about your right limit? It falls on the parabola x squared is equal to y. In that you can express x in terms of y. So here what is given? X squared is equal to y. X is equal to plus or minus root y. But I can consider only the positive roots. That is x, x squared to y squared to root y. This is your limit. After that, what we are going to do, we can move the strip from bottom to top. What about this bottom? Equation of x-axis will give y is equal to 0. What about your top? Y is equal to, it's a line parallel to y-axis with how many units? 1 unit. So 0 to 1. So y squared to root y, 10y, dx dy, 0 to 1. Okay. After that, ordinary integration. The innermost integrations with respect to x means I can retain 10y as constant. Integral of x is x y squared to root y. Now you can apply upper and lower limit. Integral 0 to 1, 10y root y minus y squared into dy. Now you can manipulate this 10 y power of plus 1. So 3 by 2. Y power 3 by 2 integral 0 to 1 minus 10 y cube into dy. This is equivalent to, what is integral of x power n? X power n dx will be equivalent to x power n plus 1 divided by n plus 1. Same thing here, 10 y power 5 by 2 divided by 5 by 2 minus 10 y power 4 by 4, 0 to 1. So if I apply the upper limit, what happened? 20 by 5 y power 5 by 2 minus 10 by 4. 10 by 4 is 5 by 2 y power 4. If I apply the upper limit on y, so what happened? 4 into 1 minus 5 by 2. Lower limit 0. 4 2s are 8. 8 minus 5. 8 minus 5 divided by 2. The answer is 3 by 2. Okay. Like this you can evaluate. See. Here I can explain all the steps in that paper. So 8 minus 5. So 3 by 2. So right hand side is over. Next what we are going to do, we can evaluate left hand side. What is your left hand side? Line integral. So what is line integral? Integral over C 3x squared minus 8y squared dx plus 4y minus 6xy dy. So here your P is 3x squared. This is your Q. So integral over C. How do you evaluate line integral? Your integral over C can be bounded by, already I told you, your C is taken in the anti-clockwise direction. Anti-clockwise direction means positive direction. Suppose this is clockwise direction. Anti-clockwise means in this direction. Okay. So clockwise means C is made up of two different curve segment or two different line segment. The curve C consists of two parts. One is along C, along C1, and another one is along C2. That means along OA, this is your C1, along AO, C2. So what is the equation of C1? C1 is a red color, no? Y is equal to x squared. So here the ranges of OA, the coordinate value of O is 0, 0, A is 1, 1. What is C2? It's a blue line, no? X is equal to y squared. A 1, 1 to 0, see the direction. Okay. Okay. So what about your P is this? Now integral over C can be split into two different line segments. C1 along OA, along AO. So OA, you know the value. What is OA? See, this is OA. That the equation is y is equal to x squared. So in that you can express everything in terms of x. So dy equal to 2x dx. So you can convert P and Q in terms of x. So P is equal to 3x squared minus 8y squared. You retain x as it is. You can convert only y in terms of x, y squared. So x power 4. Similarly for Q, you can convert y in terms of x, 4x squared minus 6x, y means y squared, x 6x cube. So you can substitute here P dx plus Q dy will be equivalent to this because dy is 2x dx. Now simplify 3x squared plus 8x cube minus 20x power 4 dx. Integral, here the ranges of x is from 0 to 1 because along OA. So 3x squared. So how do you manipulate this? 3x cube by 3. 8x power 4 by 4 minus 20x power 5 by 5, 0 to 1. 3 get cancelled, 4 2s are. Now you can apply the limit 1 plus 2 minus 4. So 1 plus 2, 3. 3 minus 4 is minus 1. This is the final answer. Similarly, we can evaluate along C2. The equation will be x is equal to y squared. So here I can convert everything in terms of y. So dx will be equal to 2y dy. So here the range limits for y is 1 to 0. Okay. Now you can convert everything in terms of y. So p dx plus q dy can be expressed as 3y power 4 minus 8y squared 2y dy plus 4y minus 6y cube dy. In the limits from 1 to 0, 6 power y power 5 minus 20y cube plus 4y dy. So here one of the property under definite integral is integral a to b f of x dx will be equivalent to minus integral b to a f of x dx. I can apply this property here. So integral 1 to 0 can be rewritten as minus integral 0 to 1. After that, as usual, now you can manipulate this. So what is integral of this? Integral of this is integral of 6y power 6 by 6 minus 22y power 4 by 4 plus 4y squared by 2, 0 to 1. So minus is outside, you retain minus as it is. So this is 2, this is 11. Now you can apply the limits 1 minus 11 by 2 plus 2. So 1 plus 2 is 3. 3 minus 11 by 2, the answer is 6 minus 11 by 2. 6 minus 11 by 2 is minus 5 by 2. Minus into minus plus. So the answer is 5 by 2. Okay, after this, what we are going to do, we can add both the C1 and C2. So integral over C can be split into two different, along OA and along AO. So I can add both the integrals value. So minus 1 plus 5 by 2, the value will be equivalent to 3 by 2. So already we proved right hand side is 3 by 2. The left hand side is also 3 by 2. Therefore, from 2 and 3, Green's theorem is verified. So one more problem I want to discuss under Green's theorem. In the first problem, we are going to verify Green's theorem. That means we can evaluate left hand side separately, right hand side separately. Finally, we can conclude that Green's theorem is verified. But here, using Green's theorem, how we are going to evaluate the integral. So no need to verify. Okay. Using Green's theorem, already we know the statement of Green's theorem. Integral over C p dx plus q dy will be equivalent to double integral over r dou q by dou x minus dou p by dou y into dx dy. This is a statement of Green's theorem. Using this, I am going to find the line integral value, integral over C p dx plus q dy. Okay, where C is a triangle with the vertices 0, 0, A pi by 2, 0, B pi by 2, 1. Okay, so what is given in the question? Sin x minus y dx. So this is your P. You just compare with the statement of Green's. This is a statement. You just compare. What is the value of P? P dx, sin x minus y. This is P. What is q? Minus cos x, because plus q dy minus cos x. Using this, what we are going to do, we are going to use Green's theorem. So left hand side will be equivalent to right hand side. So no need to evaluate line integral. You can directly evaluate a double integration that will give the line integral value, because these two are equal. So you can manipulate dou q by dou x. What is dou q by dou x? Differentiate q partially with respect to x. What is differential of cos? Differential of sine is cos, differential of cos is minus sine. So minus into minus plus. So similarly, dou p by dou y. So when you differentiate partially with respect to y, now we are treating other variable as constant. That means x is constant. So first term 0, second term minus 1. Okay, now you can substitute in this. So dou q by dou x minus dou p by dou y equal to minus sine x minus into minus plus. So I can write like this, 1 plus sine x. Okay, now you can substitute here double integral over r 1 plus sine x into dx dy. You can substitute in this formula, you will get like this. So what we are going to do here, you can find the limits for x and y. For that, we are going to sketch the diagram by using this. So 0, 0, A pi by 2, 0, B pi by 2, because C is a triangle with vertices. So how do you sketch the diagram? C is a triangle with vertices. So here 0, 0, triangle 0, 0. So pi by 2 comma 0. This is pi by 2 comma 0. Pi by 2. So what is 3.12? Okay, divided by 2 means 1 point something. So pi by 2 comma 0. And what about other? Pi by 2 comma 1. So pi by 2 comma 1. Now this. Okay, so here C is taken in the anti-clockwise direction. So anti-clockwise means we can consider this along OA, AB and BO. So how do you write this equation? This is y is equal to 0. So what about this? This is parallel to y-axis. Equation of y-axis x is equal to 0. So it is parallel to y-axis. What is the value of x in this? X is equal to pi by 2. So how do you know the equation of OB? So for this, I am going to use a 2-point formula. What is 2-point formula? Listen. Equation of 2-point formula is y minus y1 divided by y2 minus y1 equal to x minus x1 divided by x2 minus x1. So here this is x1 y1, this is x2 y2. Okay. x2 y2, this is x2 y2. Now you can substitute in this equation. How do you manipulate a line joining 2 points? That is equation of BO. Equation of BO is this. So y minus 0, y2 is 1 minus 0, x minus 0, x2 is pi by 2 minus 0. Now you simplify this. What do you get? Y by 1 equal to x by pi by 2. This 2 will goes to the numerator. So y is equal to 2x by pi. I got the same equation. Y is equal to 2x by. Like this you can manipulate the equation of BO. So y is equal to 0, x is equal to pi by 2, y is equal to 2x by pi. Using this we are going to find the limits for x and y. So the innermost integration is with respect to x. We are treating the other variable as constant. Y is equal to constant. Y is equal to constant. It's a line parallel to x-axis. So I am going to draw a horizontal strip. In this, you can find the limits from left to right. So one end of the strip will falls on the line y is equal to 2x by pi. So in that you can express x in terms of y. X in terms of y means x is equal to pi y by 2. The other end will falls on the line x is equal to pi by 2. So x is equal to pi by 2 only. So the innermost integration, limit of the innermost integration is pi. Pi y by 2, pi y by 2, pi y by 2 to pi by 2. The outermost is y is equal to 0 to y is equal to 1. So pi y by 2 to pi by 2, 0 to 1. So 1 plus sin x dx dy equal to x minus cos x. Integral of dx is x. Integral of sin x is minus cos x, pi by 2, pi y by 2 dy. So pi by 2 minus, if I apply the upper limit, what happened? Pi by 2 minus cos pi by 2. Cos 90 is 0. So upper limit is 0. Minus of the lower limit, pi y by 2 minus cos pi y by 2. Okay, so pi by 2, you can remove the negative sign, minus into minus plus. Now you can integrate with respect to y. So pi by 2y minus pi y squared by 4 plus cos pi y by 2 means integral of cos is integral of sine is minus cos, integral of cos is sine. So sine pi y by 2 divided by pi by 2. This 2 will goes to the numerator. So 2 by pi sine pi y by 2. Now you can apply the upper limit. Pi by 2 minus pi by 4 plus 2 pi. If I apply the limit for y equal to 1, sine 0 0, sine 90 is 1. For lower limit 0. So pi by 2 minus pi by 4 plus 2 pi by 2 by pi. So this is, when you simplify this, you will get 2 pi minus pi divided by 4. So pi by 4. Pi by 4 plus 2 pi. This is the final answer.